Good day. My name is Ugochukwu Ukwebu. I am a Nanodegree lead with the Udacity ALX Cloud Developer Program. And um, in this video is part of a 4 parts project walkthrough. Project 3, refactor monolith to microservices. In the part 1 of this video series, we set up a monolith application locally on my computer, on my personal computer, and we ran it and we tested that it's working as a monolith. In the part 2 of this video series, we refactored the monolith application into a microservice architecture, and we ran it locally in my system and we tested it and we saw it was working fine. The part 3 of this video series was continuous integration, where we used Travis CI to detect recent pushes to GitHub, pull the code from GitHub, build it, and then push to Docker Hub. In this part 4 of the video series, we will be using Kubernetes, which is an orchestration service, to pull images from Docker Hub into pods in our clusters in Elastic Kubernetes Service on AWS. So let's me begin with sharing my screen. All right. As always, I'd recommend to all our learners to begin with the instruction sets on the learner's dashboard. Pretty much everything you need is uh, in your instruction set. Try to follow it as best as you can. So in this 4th part, uh, we'll use, this is about container orchestration with Kubernetes. First thing we have is, before we proceed with the current part, verify that you have kubectl utility installed locally. So let me go to my VS Code environment. All right. Before I begin coding, I want to know what has changed between the last time where we're doing continuous integration to now we're doing continuous deployment. What has changed is that I created a new branch feature for continuous deployment. Let me show you what's the branches I had before. I have my main branch, I have my dev branch, I have my continuous integration branch. That's feature continuous integration. And now I want to add a new feature, continuous deployment. So I created a feature continuous deployment branch. And in between, I also added a new configurations directory that will include my deployment file, YAML files. And okay, I don't want that configurations directory to be pushed to GitHub. So I'm going to come to git ignore and add configurations there as a directory that I do not want to be tracked. So I don't want things in my configurations directory to be pushed to GitHub. So that's that. So ready to start. We will we'll go through a brief of the content of the deployment files. So just as instructed in our instruction set, let me begin with kubectl version to know what, to be sure to ascertain that we have kubectl utility installed locally. All right, so we do have it. We have client version 1.2.1.25.0, customized version 4.5.7. Of course, right now it's unable to connect to my server because we still have some configuration to do. So first step is we create an EKS cluster and node group. And here it tells us that an EKS cluster can be created in multiple ways. We can create an EKS cluster from the AWS Management Console using the EKS CTL or AWS CLI tools. Uh, well, in this lab, we'll be creating an EKS cluster using the AWS console. You can do this using the following steps. All right, so the parts where there is a part in the course where all this has been done. So I would refer you to your lesson 5, orchestration with Kubernetes on AWS. So this part pretty much details out how you create an a Kubernetes service using EKS on AWS. So this is it. First of all, you're given a sample deployment file, a sample service YAML file, and there's this video walkthrough here on how to create Kubernetes cluster. So justice has been done there. The steps, you create an IAM rules for the EKS cluster node group. Step 1, step 2, using the console. So I've pretty much done this part, but that I'm just going to deviate on, I've created an IAM rules for the EKS cluster and node group. So done that, I've created an SSH pair. And on the create an EKS cluster, I won't be doing this from the console. So I pretty much did the first 2 steps using my AWS console. But this third step, I will be creating it from my AWS CLI tool. This being that the IAM user that creates a cluster is admin. If I create it from the AWS console, it's a different IAM user, and I might not have some privileges to work on the cluster firsthand. I think you could, there's a link to documentation on, why this is so. I will just demonstrate. If you have other questions, just reach out to me and I will explain further, or I'll point you to documentation that explains why I have to take this third step the way I'm going to do it. So first of all, ahead of time, I'd prepared scripts that would help me do this, right? So pretty much, I'm going to use a script to create my EKS cluster. As always, the way to do this is well documented. So I'm going to pretty much paste that script there. So this is going to begin my cluster creation. Of course, I've configured my AWS CLI tool with my IAM user to be able to interact with my AWS account. So with that started, we can monitor what's happening. So I'm going to open a new terminal, and with that terminal, of course, continuing to have a pretty much set of a set of commands that I prepared ahead of time. The first command was to create a cluster. Second command, I'm going to try to monitor the status of the cluster creation. So let's see what's happening in a new terminal. Let me drop that command. Of course, my cluster name is my cluster, right? So it tells me the status of my cluster is creating. So if I want to see what's happening ahead of this class, I opened my console, my AWS console, and from here we can see initially there was nothing in this region here, no cluster here. But if I do a refresh here, because of that command I started, we're going to see that I'm already creating a new cluster, my cluster, right? So that's basically what's happening now. So yeah, so that's some of the powers of using your terminal to interact with your cloud account once you've configured things properly. Of course, the configuration, how to do the configuration has been well detailed in our course, in earlier sections of this course, right? So every student, as long as you've been diligent with your studies, should understand what's been happening so far. All right, so while our cluster is creating, let me take this time to do a brief description of the deployment YAML files that I've set up. So this deployment YAML files, we have the API feed. We have our services, API feed, API user, front end, and then the reverse proxy service. So that's 4 parts of our microservice that make up our uh, application. So here's a brief description of the deployment file, which has its API version apps v1, kind deployment, metadata, API feed, labels, app API feed, specs, one replica, selector, match label, templates. And this is a very important part in the container specs. The name of the deployment file or containers will be API feed. The image is going to point to, if you recall, this is the image repository on GitHub, on Docker Hub, where we pushed our built images to. So this is the exact image address with the v4a tag, image pool policies always. So basically, this is our deployment YAML file. If you want further reference on what it means, you could get those from Kubernetes documentation. Let me try to get onto that. So this is Kubernetes documentation about on how to create a deployment, and it pretty much tells us, itemizes and explains what all the steps are. What's a deployment? The deployment provides declarative updates for pods and replica set. So feel free to come on here, read what's happening, understand what's happening. Of course, there are other ways this could have been done. The other ways cluster could have been configured and pods configured, but setting it up declaratively can make things pretty much easy for us. Though the learning curve might be steep initially, steep initially. When you get used to this, it makes a lot of things easier for you going forward. So I'd recommend you come here and look things up to understand how I prepared my deployment or YAML file. So we also have our feed service, right? So of course, okay, I want to mention that at the end of the day, the container port is 8080. And I also specified 8080 in the service file. So of course, service file name is API feed, app API feed, port 8080. So we have a similar thing in the API user deployment or YAML file. API user, so same thing, pointing to the appropriate image. API service. I'm not going to open my AWS secrets, env config map and env secrets files. I think the instructions on how to create those ones have been pretty much detailed in our instruction set. So you could go look it up and, okay, let me see. Let's see what's the status of our cluster creation now. Okay, our cluster is still creating. So we could go and see our instruction set. Okay, so we're creating our EKS cluster. While that is happening, just make sure you follow instructions. If you don't have a VPC, create one with IPv4 CIDR block value, and make sure you select no IPv6 CDR block. Your cluster endpoint access should be set to public. All right. So I've ensured that with my commands. So okay, connect. Okay, we're gonna get to that. Okay, now in the deployment step, you will deploy Docker containers for the front end web application and backend API applications in their respective pods. Recall that while splitting the monolithic app into microservices, you use the values saved in the environment variables as well as AWS CLI was configured locally. Similar values are required while instantiating containers from the Docker Hub. So recommended, these are the YAML files that we'll need that will save our config maps. During the course, these config maps will explain the differences between a config map and uh, a secret. So save all your configuration values, non-confidential environment variables in config map. The confidential ones, we save it in secret, but that's after encoding the values to base64. Instructions are pretty clear on how to go about all that. And how you go about it might differ slightly based on your OS environment. My environment is Windows. The approach for Mac is a little different, but everything leads to the same result or similar result. So mine is I'm developing on a Windows machine, and let's see, what's it? Normally cluster creation takes about 10 to 15 minutes. Okay, our cluster is still creating. So let's still keep looking at our instruction set. So we're going to have our deployment configuration. Okay, and we advised how to go ahead about this. Of course, when you become more proficient with using deployment files and scripting, you learn to prepare your commands ahead of time using files. So pretty much just like our course instructed, I've set up my commands, they're pretty ready, and I'll be applying them as we go in the appropriate order. So that's what this section is all about. We're going to apply our AWS secrets, our env secrets, env complete map, backend feed deployment, backend service, the YAML files. And well, when we get there, we're going to connect to the Kubernetes services to access the application. We're going to take the steps. We're going to explain this. So this is this is the architecture we strive to achieve. So basically, a pod will have containers. A pod consists of one or more containers. So notes regarding Kubernetes deployment. A kub has containers running inside it. Each pod is meant to run a single instance of a given application. A service is an abstraction to a set of pods and has a unique cluster IP. Service ports, the port exposed to the outside services. Service target port is the port the container accepts traffic on. In other words, it's the port on which your application is running inside the container. So you might want to gain further understanding of what's happening. You view this architecture diagram, and then you can go on to even you with this tutorial, right? There's a tutorial on a stateless application, how to expose external IP to show you how to explode external address on the front end service. So we're going to actually run these commands, and I'm just doing a brief overview of the steps that we're going to take while our cluster is building. We're going to take these steps. When we come here, we're going to expose reverse proxy deployment and front-end service or front-end deployment. And then we're going to use the external IP, the expose to access our cluster. When a cluster is created, it's created with a default cluster IP. And with that cluster IP, we can't access the containers from outside the cluster environment. With cluster IP, we can only interact with the clusters from within, or with the pods or containers from within the cluster. There are different types. We have the cluster IP, node ports, load balancers. They have their differences. But if we want to interact with the application inside our containers, we interact with them through using load balancers. And that's basically what's going to happen when we expose our services here. These are the steps we're going to take. When we get there, we're going to do the right thing. So let's see what's the status of our pod creation or our cluster creation. Okay, it's now active. So that means we are good to go. But before we go, there's one more step we need to do to be able to interact with our pod. We need to update kubeconfig. We need to update kubeconfig. So after updating kubeconfig with that command, without this, we won't be able to interact with our cluster. So at this point, we've created a cluster. Like I said, I was following the instructions in this lesson, orchestration with Kubernetes, in our course outline. I told you I'd created my IAM rules and EKS cluster node group. I've created an SSH pair, and I just use command line to create my EKS cluster, right? So that's my only deviation from the set of instructions on lesson 5, orchestration with Kubernetes. And then now I'm going to create a node group. I'm going to do this from the AWS console. So I come here, right? So if I refresh this, we're going to see that my cluster status will has changed to active. So here I'm going to come in. I'm going to come to the compute tab. Okay, first of all, let's be sure that from our terminal we don't have nodes running. kubectl get nodes. So no resources found. It tallies with what we have here, 0 nodes. So here I'm going to add a node group. I'm going to name the node group my node group. I'm going to select a role for the node group. The role I select is EKS node role. Okay, I go next. Okay, instance types, we're recommended to use M5 large. We advise to use M5 large to run application. That's M5 large. Minimum size 2 nodes, maximum size 3 nodes. Yeah, minimum unavailable 1. So I move to the next. Select subnets. Yeah, so this is the subnet I created ahead, and I'm okay with those. I think no, basically I think I'm using default subnet here. Configure with SSH. Yeah. EC2 key pair, one I had prepared ahead of time. Security groups. Okay, let's select these. Do not restrict source IPs that can remotely access nodes. When we become more advanced users of Kubernetes, we will know how to refine those permissions. So things are looking good here with so I go ahead and I create. So our node group is creating. While our node group is creating, we won't be able to interact with it. So we need that node. The node groups actually, they are composed of EC2 instances. The type of EC2 instance we're using is going to be M5 large. So yeah, basically nodes are actually virtual machines still, right? So in our case, it's M5 large EC2 instances we're using to run our cluster. Well, that's part of our cluster to run our resources. So let's see what's the status of kubectl get nodes. Okay, it's still not finding resources yet because our node group is still in the creating phase, right? So we just wait maybe another 10 seconds and repeat that command. Kubectl get nodes. All right. So this time around, uh, it found that we have nodes being set up, but the nodes are on, but still not, the status of the nodes not ready. So let's see the status of our nodes now. All right. So the status of our nodes has changed from not ready now to ready. Age, it's about 1 minute. So we're ready to interact with our clusters. First set of commands, create to apply environment variables. Just like I said earlier, I've prepared these commands ahead of time. I'm not going to expose the content of those files for obvious reasons, but instructions on how to set them up are well detailed and linked in our course materials. So just follow them out and you'll be fine. So I pretty much paste those commands and enter. And yeah, secret created, env secret created, config map created. So next set, pretty much review these two. I think we've done that together. I want to apply my deployment files. Okay. API feed created, API user created, front end created, reverse proxy created. So next thing, uh, apply the service files, the first service files. So I'm going to apply them all together. Yeah, API feed service created, service API user created, service front end created, and service reverse proxy created. So, okay, next thing, let's check our deployments. Kubectl get deployments. And after get deployments, we expose the front end deployment. So let me first do kubectl get deployment. All right, so our deployments are looking good. Why is my front end not deployed? Let me look at that very well. Uh, front end. I hope I put the right image there. V4A. Autogram front end too. Okay, let me try that again because that's unusual. Something is wrong. Background front end. Front end deployment. Let me be sure of what I have in my Docker. Background front end too. Oh, okay. Front end should be local. I don't have that image up there. So front end should be local, should be tagged local for now. So that's interesting, right? So if you look at it, my tag is local, but I was referencing V4A here, which wasn't available, so you couldn't pull it. So I make that update and I run that front end deployment again. So this time around, I just do just that one. Yeah, so you didn't see that image. I was pointing to an image, a non-existent image. So you didn't see it. It pretty much didn't do anything. Why is it telling me front end not change? Not deployment, front end deployment. I changed that. Okay, configure. Yeah, so it's pretty much configured that. So let me see my deployment again. All right, so that's good. Front end available too, right? So I think it was good for that to happen, so we can see some of the things that could go wrong while we are setting up our services. So I think I've done my services. Okay, I think I've applied my services, but let me check. kubectl get services. All right, so basically our services are up, API feed, API user, front end, Kubernetes, and reverse proxy. So we can see all of them set up. Default settings for services is cluster IP. None of them have an external IP. But when we expose the front end and the reverse proxy services, they will be configured, they will be given external IPs by the cluster service. So that's the next command. kubectl expose deployment front end. Let's be sure that, okay, expose deployment front end. Just want to be sure that our services are appropriately named. Reverse proxy. So kubectl expose front end with type load balancer with name new public front end. So that's exposed service front end exposed. Let's do kubectl expose deployment reverse proxy. So reverse proxy exposed. So let's run kubectl get service again. And we see this time around our front end and our reverse proxy have been given new external IPs. In this case, this is what the external IP looks like. Let me try and give it a better relaxed view. So we can, let's see what our instruction sets for. Let's go back to our instruction set. Let's see what to expect there. Okay, part 4. All right, so if the deployment is successful, the services are created. There are two options to access the application: forwarding IP, expose as external IP. So we probably use exposed as external IP. Below, we have explain method 2 as mentioned above. So that's what I did here. Get services, get boards. So what we have in my screen is equivalent to what we have here right now. So this is how we're going to access our application. So let's take that endpoint and go to a browser. Let me come here. Let me open the new browser tab here and try to expose our application. Try to access our application. All right, so that's good news. We are able to access our application using the um, front end external IP. So currently there's a failure with trying to access the API feed. That's because we still need to set up the reverse proxy. So we know we're no longer in our local environment. So let's get on with that. Let's still look at our instruction sets. Probably tell us the next step to do. Basically, if you look at this, we're to replace the keyword port localhost in this in the string of external IP. So we're gonna make those updates to environment variables and deploy our application. So that's this this part of the uh, set of instructions. So I'm gonna do that now. So basically, it's the we access our application using the public front end external IP. So we use the public reverse proxy external IP. We'll take that copy. And just as instructed, this chain, we're going to make it in the Udacity front end subdirectory environments here. So we come here, we replace localhost with that external IP. So let's delete that and then put that. And then let's change this to Udacity application, Udacity microservice application. Yeah, that's good. So let's save that. And let's go do that to the environment.ts file. Same here. Delete that and put that. So uh uh Udagram microservices app. All right, so we save that, and of course, let's be sure updates Udagram front end source environment.ts file, replace the keyword localhost with the external IP of reverse proxy deployment, for example. I will do that for Udagram front end source environment pro.ts file in the same way. Okay, so we're not going to build a new front end image and push Docker Hub. All right, while building a new image, it is recommended to use a different tag name each time as shown in the example below. So that's why in our instructions, the initial tag name is front end local. So this is the time to update the image from front end local to I think we're gonna do that. We're using Travis, right? Where we make the changes in our Travis.yaml file. You go to Travis.yaml file. So everything pretty much the same, but here we change our image tag from local to v4a, right? You know, right now, v4a doesn't exist. What we have on our Docker Hub is local, and we're gonna update this one too from local to v4a, right? So let's save that. So we made some changes to our code base. Let's see what changes git start. Oh, no, git status. All right, so we've modified git ignore. We added this configurations folder to git ignore so it's not pushed to GitHub. We've modified our Travis.yaml file to point to we're about to build new images, and we'll be updating the tag for the Udacity front end app to be from local to v4a, and we've updated the front end source environments / environment pro.cs file with the reverse proxy external IP that we've been provisioned with on AWS Elastic Kubernetes Service. So I do a git add all our changes, git commit. Let's see. Okay, added uh, reverse proxy external IP address to code base updated Travis to build front with v4a tags. So git commit, git push origin feature continuous deployment. So just as a refresher, from what we set up in part 3 of this video series, where we set up our continuous integration pipeline. When we push this to GitHub, Travis is going to detect that we've made a push to GitHub, and it will trigger Travis to pull that code base to Travis, and then build a new set of images and push to Docker Hub. So let's come to our Travis file. Things are active here. So let's see if it's going to detect that change there. All right, so you can see that run is 0 of 1. Scene 1, it has detected a new job to run. It's been queued, and it will soon start. All right, so that's it. A build started. Of course, to do all this, just follow instructions in the relevant section in the course. Set up your continuous integration pipeline. Here we set in this phase of part 4, we're setting up the continuous deployment part, right? And this time around, we're preparing to pull from Docker Hub into our Kubernetes cluster on Elastic Kubernetes Service, Elastic Kubernetes Service on AWS. So let's see what's happening here. Just as always, pulling, is this for this? Yeah, it's for this build. So it's just pretty much doing all the things we asked it to do. Let's see if we have something to prepare ahead of time. We're building with a new front end. All right, so basically we're redeploying the new front end image to the Kubernetes cluster. You have to update the image tag in the front end deployment or YAML file. Okay, so let me go and see. Okay, front end deployment or YAML file. Yeah, initially it was okay. We went ahead of us as ourselves in that time to give it. So this time eventually, let's push to Docker Hub. Be sure that it has deployed. Then we update the front end deployment tag. So let's see the status of our Travis build. Of course, we've reviewed Kubernetes documentation on deployments. This is the Kubernetes documentation on secrets. Okay, let me just, there are different approaches. Okay, let's see, how did I expose my secrets? I exposed my secrets, okay, not here. We're going to say that in the API feed. I exposed my secrets as container environment variables. So we can do a brief, if we go through the documentation on Kubernetes secrets, there are different ways to expose Kubernetes secrets to your application running in containers. So from documentation, working with secrets, editing a secret, using a secret, using secrets as files from a pod, Projection of secret keys to specific paths, secret file permissions, consuming secrets as volumes. Yeah, these are ways of consuming secrets. One option is to consume secret values from volumes. Mounted secrets are updated automatically. Yeah. Using secrets as environment variables. In our case, uh, we'll be using secrets that container environment variables. So what I have in my secrets.yaml file or msecret file, AWS secret file is similar to this. I pretty much have a kind API, a file, a YAML file of API version v1 kind secrets metadata. I named it, I think AWS secret, AWS secret type opaque data, username, password, username, I use a service to decode my username to base 64, and same thing with the password. And that's basically the same structure that my secret file is. And I did the same thing for the AWS. This is M secret. I did the same similar thing for AWS secret. Let's see the status of our Travis build. All right, still moving. So I'd recommend come read up your secrets to see how things are happening. Same thing with deployments. And pretty much you can find, okay, there's a kubectl cheat sheet. Any topic you're interested in, just go there, go to your Kubernetes service, and there's a search tab, there's a search field there. Search what you're looking for, and I could do config maps. And we'll see it leads us to with link, it gives us links, it returns links to config map documentation. And yeah, I, I I looked this documentation up as a guide on how to prepare my config map too. So I recommend you to come here to look at your Kubernetes docs concepts configuration if you need to. All right, so we've uh, built new images and pushed to Docker Hub. Let's go confirm from Docker Hub. Let's see our repos. Let's refresh this. All right, a few seconds ago. So let's say our front end images, and we see we have local, and we just put v4a a few seconds ago. So I go back to my cluster and redeploy this front end deployment. Oh, but just for the sake, I think doing only that would have been sufficient. But just to err on the side of caution, let me apply all those deployment files again. So I come here, I do that. I go ahead and do this. Yeah, API feed configured. APIs are configured. API front end configured. All right, so if I do kubectl get deployment, I have that kubectl get services. Okay, this time around, let me use the full name. All right, so let's take our public front end external IP and try reach it again. This time around, let's see new browser. Okay, why is it telling me that? This happens when mm, why is it failing? Let's refresh this. So let me look at my front end files again, and be pretty sure I did everything properly. Mm, everything looks good here. Everything looks good here. Everything looks good. I really feel I've done everything properly. Let's hope it's not taking time to propagate. Mm, 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 mm. I hope I'm not suffering from cache error. Mm, 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 mm. Okay, let me close this and bring it back up again. Time for to clear cache. Okay, let me close that again. I'm gonna close that again. Let me look at this. Let me review this again. I'm going to apply my services again because everything looks good. This doesn't look like a necessary step, but let me take it. So let's take that again. Hmm. What do I need to update here? Okay, let me see what troubleshooting I might need to do. Everything is looking good. So why are we not able to make a clean connection with our database? All right, let me try this in another browser. Hmm. Normally, when this happens, there's just all right. Let me look at my ports. All right, so let me log my API feed, one of my backend ports. Okay, so we have initialization happening there. So things look good there. Uh, Let me look at my front end port. Okay, things are looking good there too. Okay, let me see my reverse proxy. Okay, so I'm getting client closed while waiting. So something not so fine here with the reverse proxy. Let me review my Travis file. What's not so happening here? What am I not doing? No tag. So my reverse proxy. Let's see this. Things are looking good here. Anything odd here? Everything looks good here. Okay, API feed, API user. Let me look at my reverse proxy deployment file. Okay, let's look at this better. Reverse proxy to A. Reverse proxy. Container port 8080. Okay, let me compare my kind of files. So why am I getting client connection closed? Let me see. Server to 8080. Should I make more requests for the resources here? Uh, Connection time closed while waiting for request. So what's happening here? Client closed connection while waiting for request, which so let's see. What are we not getting properly right here? API feed 8080. Reverse proxy. What's the name of our reverse proxy file? Our reverse proxy service. reverse proxy, reverse proxy. Okay, let me do a couple of things again. This shouldn't change much though. Let's see. Why is it saying configured when it doesn't look like I made any change there? Uh, let's do. Okay, service unchanged. All right. kubectl get deployments. Okay. kubectl get services. All right. So let's try to access our endpoint again. Because let's try this from a different tab. I'm still getting that. All right. So let me see. I'll give this one more try. Let's come here. Okay. API v0 feed unknown. Again, same thing here. Same thing here. And try that again here. All right. So it looks like we have a whole new troubleshoot. This calls for a troubleshooting section. But so far we've got a lot of things happening. So I'm gonna everything looks to be going good, right? But this video is getting long, so I'm going to pause it here. This calls for another part, a troubleshooting section. So let me pause this video here and expect a fifth part, troubleshooting. But everything has so far has gone good here. I think it's just a little bit poor connection happening in our reverse proxy service file. I don't know if I have enough time to look at it here. Let me see. Let me re-expose that service. Let me do this too again. I suspect it's going to be unchanged. Yeah, already exists. Already exists. All right. So let me go look in detail what's happening, and I'll come back with a troubleshooting section of this, right? But if you follow through, you're almost done. We're pretty much at 80 or even 90% done. So let me go look into the details and see where things might have gone wrong and come back with a troubleshooting section, right? So let's stop this here. End this recording.